In this video lecture, I am going to start a new section of EE 280 Introduction to Electrical Engineering 1. The section is on transformers. These are the subtopics that I am going to cover under transformer section. First, I will give you an introduction to transformers. Then I will look at the construction of a transformer. After that, ideal transformer, dot convention, impedance transformation, real transformer, finally estimating parameters of a real transformer. This section will be covered in several video lectures. In the first video lecture, I will introduce a transformer and its construction. Ideal transformer, dot convention and impedance transformation will be delivered in the second video lecture. In the third video lecture, real transformer will be introduced, and in the final video lecture, I will discuss how to estimate the parameters of a real transformer. Already, I have uploaded the gap handout corresponding to transformer section, so you could fill the gaps while you listen to the lecture. First, I will give you an introduction to the transformer. Transformer is a device which is used to step up the voltage or step down the voltage. Here we use the AC voltage. How we perform this action is using a electromagnetic energy transferring. So this is a block diagram representation of a transformer. You have an input and an output. If the input voltage is higher than the output voltage, then it is a step down transformer. Second type, if the input voltage is less than the output voltage, then it is the step up transformers. These are the commonly used symbols of a transformer, and the first one represented in this figure is more commonly used than the second one. In the first one, you have the primary winding and the secondary winding and its voltage and currents. Two dots to represent the polarities of the voltage and current, and this what type of a core is used by these elements. And this is the other transformer symbol, which is mainly used in the single line diagrams. When it comes to applications, you could find transformers mainly in power systems to step up the voltage and step down the voltage. The step up transformers are mainly used near the generation units, and the step down transformers are used in the distribution network of the power system. These transformers are going to be bulky and they are large in size. I assume that all of you have seen transformers which are used in power systems. Then the other applications of transformers are in electronic circuits. So if you dismantle a CFL lamp, computer, laptop charger, phone charger, in all of these devices you should be able to find a transformer. When you compare the size of the transformer used in these electrical circuits, they will be much smaller than the transformers which are used in the power systems. You could classify the transformers in different ways. The first classification is number of turns. Commonly used type of transformers are single phase transformer and three phase transformer. And then you can classify based on the frequency, low frequency transformers and high frequency transformers. Low frequency transformers are mainly used in the power system application, so where the operating frequency is similar to the power system frequency. The second type is the high frequency transformers. They are mainly used in the electronic circuits. A transformer will have two main components. One is the core and the second one is the winding. I mentioned that transformer is an electromagnetic device. Therefore, there should be a path for the flux flow, which is going to be the core, and the electrical parameters, current and currents are going to flow in the windings. So this is a image of a transformer which you could see in the laboratory. Transformer cores are available in different geometries. So here I have drawn three core shapes, but in real world you could find many other shapes for the transformers. So here this is a EE core, CI core, and this is a EI core. And the main function of this core is to provide a path for the magnetic flux for circulation. Steel iron, ferrites, iron powder are some of the materials that are used for cores. Steel iron type are mainly used in the low frequency transformers. Ferrite iron powder can be used in the high frequency transformer applications. Then you have the windings where the voltage source are connected or the loads are connected, and the currents are going to flow through these windings. So in a simple transformer you will have two windings, one in this manner and the second one in the other way. But in some other transformers you may have more than two windings. Typically we are going to use the insulated copper wires for the windings. The reason is to use the insulation is to avoid short circuit in the conductor. In a simple transformer, as I mentioned, you have two windings. One winding will be connected to the supply or the source, and that winding is known as the primary winding, and then the remaining winding is going to connect to the load. That winding is known as the secondary winding. So the windings can be wound in different ways. So here I have represent the two types of winding placement methods. The first one is known as the core form and the second one is known as the shell forms. In the core form, part of the winding would be wound in one limb, whereas the other part is going to wound on the other limb. So if we take the primary winding, half of the winding would be in this limb and the other half would be in the limb of this one. Similarly, in the secondary, half would be in this limb and the other half in this limb. In the shell form, both the primary and the secondary winding would be wound on a single limb. Depending on the voltages that you are going to apply to the primary and what you are going to expect at the secondary, the number of turns in the primary and the secondary would be different. If you want to get the same voltage, then the number of turns are going to be same. And then the cross-sectional area of the winding would depend on the amount of current flowing through each winding. If the current is high, then the cross-sectional area would be high. If the current is less, then the cross-sectional area is going to be less. So with that, I am going to conclude the first video lecture. In this video lecture, I introduced the transformer and looked at the construction of the transformer. So these are the references that I used in this video lecture. Thank you.